Alrighty, today we're going to continue on with our derivatives and focus on some more advanced differentiation. So we're going to use a lot of the things that we did in the last unit and build on those as we go. So today we're going to focus on higher derivatives. And higher derivatives are obtained by repeatedly differentiating a function. So if f prime is differentiable, then the second derivative, denoted by f double prime or y double prime, is the derivative f double prime equals d dx of f prime of x. Okay, so first problem here. In the figure and table below, describe the total household energy consumption E of t in Germany in year t. Discuss E prime of t and E double prime of t. Okay, so this is E of t here. And if you remember that E prime is the rate of change, so since our function here is increasing, our rate of change is positive. Okay, so if the function is increasing, that means the rate of change is positive. So our slopes are all positive. Now, if you look at the steepness here and how steep this is, it's getting less and less steep. So that means our E prime is decreasing because it's getting less and less steep. So that means E double prime would actually be negative. And we're going to build on that in the next couple sections as far as looking at graphs and how they're related, but definitely in the next unit as well. Okay, number 2, ignore my spelling and grammar check there. Compute f triple prime for the function. Okay, so we need to find the third derivative. So the first derivative uses the same rule. 5 times 3 is 15. Take 1 from our exponent. 2 times negative 2 is negative 4. Take 1 from our exponent. Negative 2 times 7 is negative 14. And take 1 from our exponent. Okay, we're going to do it again to find our second derivative. So we get 60 x to the third minus 4, and then plus 42x to the negative fourth. And then f triple prime of x is going to be 180 x squared. This becomes 0. And then negative 4 times 42 is negative 168, and then take 1 from that exponent. So what we're going to do is plug in negative 1. So we have 180 times negative 1 squared minus 168 times negative 1 to the negative fifth. And we end up getting 180 plus 168, which is 348. Okay, so because this is an odd exponent, that's going to stay in negative 1, and then we can simplify from there. Okay, next one. Calculate the first 4 derivatives, then find the pattern. Okay, so y prime is negative 1 x to the negative 2. Double prime is 2x to the negative 3. Triple prime is negative 6x to the negative 4. And then for this, we usually write a 4 there instead of 4. Actually, it says first 4 derivatives. The fourth derivative is going to be 24x to the negative fifth. What you'll notice here is that our sign changes. Okay, so the way we show that a sign changes is negative 1 to the n power. And then we always have x to the negative n minus 1. Okay, so the first derivative is negative 2, so negative 1 minus 1 would give us the negative 2. And then what we're doing here is a factorial, and it's been a while since you've seen that, but like 6 factorial means we're doing 6 times 5 times 4 times 3 times 2 times 1. So you'll notice we multiplied by -1, then 2, then 3, then 4. That's where the n factorial comes from. So this is kind of our general rule here. Okay, next we're going to find the first 3 derivatives of that function and see if we can come up with a rule. So remember 1d2 plus 2d1. And I'm actually going to factor this out. So I have e to the x times x plus 1 to see if that helps us. And then I'm going to do the second derivative using this. So we have 1d2 plus 2d1. So if I factor out that e to the x again, I get e to the x times 1 plus x plus 1, which is e to the x times x plus 2. And then the third derivative is going to be 1d2 plus 2d1. And then I'm going to factor out an e to the x, so I get 1 plus x plus 2. So hopefully you're seeing a pattern there. So FCN of x is going to equal e to the x times x plus n. Okay, so our number just keeps increasing in our parentheses there. Okay, connection here. First derivative is position. Second derivative is velocity. Third derivative is acceleration. Sorry, original function is position. First derivative is velocity. Second derivative is acceleration. Third derivative is actually called a jerk, and we'll come to that later on. So find the acceleration of a ball tossed vertically in the air from the ground level with an initial velocity of 12 meters per second. How does A of t describe the change in the ball's velocity as it rises and falls? So our function is s of t equals negative 4.9 t squared plus 12t. If we take the derivative, we get our velocity, so we get negative 9.8 t plus 12. And then if we take the derivative again, we get negative 9.8. So what we found is the acceleration is negative 9.8 meters per second squared. So as the ball, if the velocity is positive, okay, and my acceleration is negative, that means it's slowing down. And then as my velocity becomes negative and my acceleration is negative, that means it's speeding up, but it's falling or going backwards. Okay, so this is going in a positive direction with a negative acceleration versus a negative direction with a negative acceleration. This means slow down, going up. This means speeding up, going down. Okay, difficult concept to understand, but if you've taken physics, you've seen that before. Okay, graphical insight. We can visualize. Okay, so if we have a big second derivative, that means the tangent lines turn rapidly and they're very steep. A smaller second derivative means they turn slowly. And if you have a line, the second derivative is 0, so the tangent line does not change. Okay, so identify curves 1 and 2 in the graph here. In B, as the graphs of f prime or f double prime for the function f. So notice in my original function, my tangent line, the slope is negative, and then my tangent line, the slope is positive. What that means is my derivative is going to be negative or below the x-axis, and then positive or above the x-axis. So this is actually f prime. Now, if you think of this way, notice that here we are increasing. That means the derivative is going to be positive. Because we're always increasing, the derivative is always positive. So this is going to be f double prime of x. Okay, again, we're doing a lot more with graphs in the next unit. Okay, here's your summary. You can kind of look through that in your book. And then I did adjust your assignment a little bit from your packet. Take 51 off of there, and then go ahead, have fun.